Good morning. Today we'll start with the session on linear data structures using linked organization. So we'll start with linked lists. So first, what is linear data structure? Data structure in which data is organized in a list or a straight sequence. Adjacency relation or one-to-one relation can be represented using linear data structures. So we have two types of linear data structure. One is array and the second one is linked list. And both of them we are going to study in the upcoming lectures. So basically, what is sequential organization? It means that data is stored in a sequential form, that is a consecutive memory location. For example, array. So there are two basic operations that are performed on this type of data. One is sorting data at a desired location, storing data at a desired location, and second one is retrieving data from the desired location. Now we know the concept of array. So when we declare an array, a block of consecutive memory will be allocated for that array. So it will not happen that one array element is at one location, the other array element is at other scattered location. No, when we declare an array, we will get a chunk of memory, a block of memory, and all array elements will be stored in that block itself. That too in a sequential manner. So check out the storage representation for the array. So this is the one-dimensional array. For example, if I declare integer a of 10, that means I want to store 10 integer elements. So I will declare an array. The name of the array is a. This is how the arrays are defined. Now when I say integer a of 10, that means I need to store 10 integer elements. Suppose one integer requires 4 bytes of memory. Okay. So to store 10 integers, I will require minimum 40 bytes of memory. So 40 bytes memory chunk will be allocated for this array A. So as you can see, this is array A and it has 10 elements. The array index starts with 0. So from 0 to 9, that means total 10 elements will be stored in this array. The first element, say 10, value 10, it will be stored at A of 0 location. The second element, 20, will be stored at A of 1 location. The third element, 30, will be stored at A of 2 location, and so on. Right? So array index start with 0 and every value will be stored in an array at a proper location in a consecutive manner. Now what is the drawback of this array? Right? All we know that we can store the similar kind of elements into the array. Like I can create a array of integer elements which will store only integer. I can create an array of double elements which will store only double, and so on, and in a consecutive memory. That's what we have seen. But what is the drawback of using arrays as a data structure? Very first is, it is very difficult to insert or delete middle element. It involves a lot of shift operations. Now check out. Suppose we have an array of 10 elements, just now we declared, and I want to insert one element at third position in the array. So what will happen? If you want to insert at third position, every element after third position, that is the element at fourth position, the element at fifth position, sixth, seventh, eighth, ninth. So every element I have to shift by 4 bytes. So there are a lot of shift operations. And suppose I want to delete, the element at say fourth position, then in that case, I have to move up all the preceding elements by 4 bytes, right? In case the array is of 10 elements, it seems to be fine. Okay, 6 to 7 shift operations we have to do. But think if your array is of big size, say 100 elements, 1000 elements, 10,000 elements, then that many shift operations we have to do, and it is not the easy task, or it is time consuming task, right? Unnecessary task. To add one element or to delete one element, if you have to do thousands of shift operations, obviously it will not be a beneficial one. Second one, overall array representation is time and space inefficient. So we cannot have exact judgment of size. Like for example, I want to store 100 elements, right? I know in the initial phase I want to store 100 elements, but later on it can scale up to 1000, 10,000. So I don't have exact idea how much size of array I need to declare. So when you don't have the idea, you declare an array say of 100, right? Suppose I will declare integer a of 100. So how many bytes will be required? Say 400 bytes of memory chunk will be allocated. But later on I'll decide that no, I will store only 5 elements in this. Okay, so rest of the 95 elements you have already reserved a memory and you are not using it. So it is a wastage of space. No one else can claim that memory, or no one else can use that memory because it is already reserved by your array, right? So it is a inefficient space management, right? And beforehand we don't know exactly how many elements we are going to store in an array, so we generally randomly we just declare an array of some size and we use a little of space from that reserved memory, and remaining space will be unutilized and wasted. So to avoid all these problems, we need to learn linked list. I hope you are with me and you're getting everything. Now let us start with the linked list. So if array is clear, we will start with the linked list. So what we have seen, array is a sequential memory linear data structure. It occupies the sequential or consecutive memory. And what operations we can do on array, like adding the element, deleting the element, it is quite expensive because a lot of shift operations are involved in it. And similarly, beforehand we have to declare the array size, and it leads to wastage of memory. So space wise and time wise, arrays seems to be inefficient. And to overcome these problems, we have another data structure called as a linked list. So concept of linked list, we have to see linked organization. There was a sequential organization. Here it is a linked organization. Data is arranged in a linked list. So memory allocation to nodes is random. Means what? I can store my first element at one position, second element randomly scatteredly at another position, third element at yet another position, and afterwards I can set the links. Okay, so it is a dynamic data structure. Nodes are allocated or deallocated as per the requirement. So very important, dynamic data structure. I want to add a node, I will create a node and attach it to the link. I will add one more node and attach it to the link. So depending on my requirement, I can create the nodes and link them to the existing linked list, right? So there is no beforehand memory allocation and it will save our space. So as per requirement, I'm going to create the elements or nodes. So linked list, what is linked list? It is a set of nodes. So the basic operations that we can perform on linked list, like we can insert element or nodes, we can find out our element from the linked list, we can search for it, we can delete any node which is not required, we can print the whole list and so on. Now there are four major types of linked list: single linked list, double linked list, circular linked list, generalized linked list. So first is, say, single linked list. What do you mean by single linked list? So as per the diagram, this is a very simple generic linked list diagram. So see, linked list is a set of nodes. So as you can see here, there are three nodes, A, B and C. Okay. So linked list is a series of connected nodes and each node is connected to one another. Say A is connected to B, B is connected to C. Now each node contains two parts. So as you can see, there is a brown part and there is a blue part. So the first part, a piece of data. In the first part, you have to store the data. Now linked list can store your integers, linked list can store your doubles, that means your numericals, it can store strings, it can store your characters, and what type of data you want to store on it, right? So the first part contains the data, and check out the second part. Second part is a pointer to the next node in the list. Okay, second part is a pointer to the next node in the list. This is how the connection or the links between the nodes gets established. Okay, so every node has two parts. In the first part, we are going to store the data, and in the second part, we are going to store the address of the next node. It establishes a link between the two nodes. Okay, then there is one more important concept of head. Head is nothing but a pointer to the first node, right? We have to, start the list, or we have to traverse the list. So from which point actually we should start? So there is a head pointer, and this head pointer will always point to the first node in the list. And as you can see, the last node points to null. There the list ends. So here you can see A, B, C. These are the three nodes. First node is A. It is pointed by head pointer. The last node is C. It points to null. So as you can see in the blue part of C, there is a null. Means there is a list is ended over here. Okay. Now we have seen that there are four types of list. I told you on the previous slide there are four types of list. So whatever we have seen right now, it is a single linked list, right? A general concept of linked list. So it is called as a single linked list. In single linked list, you can traverse only in one direction, right? From A to B you can go, and from B to C you can go. Now there is another type of linked list called as a double linked list. In double linked list, there is reverse pointer also. Okay, so you can go from A to B and B to C, and you can also come back. You can come from C to B and B to A. So there are two pointers in between each uh, pair of node. One pointer travels from A to B, and the second pointer travels from B to A. Likewise for other pair of nodes also. So using double linked list, we can traverse in forward direction also, and we can traverse in backward direction also. So both way navigation is possible. In single linked list, only forward navigation is possible. Then third type of list was circular linked list. Circular linked list is such that the last node will point to the first node. Okay, last node will not point to the null. Last node will point back to the first node, and it will complete the circle. So we can have single circular linked list, we can have double circular linked list. Okay, and the last one was generalized linked list. So generalized linked list is list of linked lists. Like every node can have singular atoms, or every node can in turn have lists. So that is quite complex concept. We will see it afterwards in the upcoming lectures. But generalized linked list is a linked list itself, but every node can in turn be a linked list. Okay, so linked list of linked list, you can say it is a generalized linked list. Now these are the four types of linked list that we are going to focus, and before we move in details of the linked list, let us discuss arrays versus linked list. So as it can be seen from the diagram, already we know regarding the arrays. So array requires a contiguous memory locations. Array index starts with say 0, 1, 2, 3 and so on, and we have to store the arrays beforehand. Okay, memory we have to declare beforehand. Whereas as you can see, linked list is a linked organization. It is not a sequential organization. So you have created here a linked list on the right hand side, and you can see the very first element is 66, and it can links to 72. 72 can link to 74. Okay, then 74 is linked to 85, 85 is linked to 96, and there the list ends because it has a null pointer, null. Okay, so the nodes can be scattered in the memory, and you just have to point them, you have to connect them with the pointer, and they will form a linked list. So this is how the array versus the linked list is there, the presentation, right? Let us talk about our coding, C++ representation of a linked list. Suppose you have to develop a linked list using C++. Okay, so very first thing is that you have to create a node, and to create a node we are going to use a class. So I'll declare a class node. Okay, now in the node we know there are two compartments or two sections. The first one is data. Now data can be integer, data can be double, data can be float, data can be character. So right now for simplicity purpose we will take integer data, right? So in a class node I will create a public section, and there I will declare the first part, that is integer data. The second part is a special one. It contains the address of the next node, and we know if we are going to store address, that field is a special field and we have to declare it as a pointer, right? So check out node star next. This is a pointer field, so I have to give star, right? Then what is the name of that pointer? Next. Okay, next is the name of the pointer, and to whom it is going to point? It is going to point to the next node. That is why its data type is node. Okay, so node star next. So this is how you are going to create the nodes using C++. I'll repeat, we have to declare a class node. In the class node there are two parts. First part will store data of type integer, so I will declare integer data, and second part will hold address of the next node. As it is holding address, it has to be a pointer, so name of the pointer is next, star because it is a pointer, and it is pointing to whom? It is pointing to the next node. That is why its type is node. So node star next is my second field. I hope it is clear. Now one node I have created. Okay, let us talk about the total code for it, for the class. Okay, to create a node. So I'll write down class node, integer data, node star next as a pointer. Then here I have written two constructors. The first constructor is a default constructor. It will not take any argument. I have to just initialize data. I will initialize to 0, okay, or any random value of your choice, and next should be null. Next is equal to null, because this is the only node. Okay, one node I am going to create. Single node hota hai, so I will write some data, okay, and it should be pointing to the null, because abhi link nahi create hua hai, ek single node create hua hai, right? Similarly, you can create the node with the help of parameterized constructor also, constructor overloading. So I will declare one more constructor called as a parameterized constructor over here. There I will pass the data. Okay, data I can take from the user and I can pass. So node, it will take only one parameter, that is integer data, and this data is equal to data, and this of next is equal to null. The current object, this pointer क्यों is क्या है? The current object which is being constructed, uska data is equal to data, and uska next pointer will be the null. Okay, in both the cases एक एक ही node हम लोग create कर रहे हैं, तो null will be the next pointer. Okay, so either we will create with the help of default constructor or a parameterized constructor at the time of actual creation of objects of node. So this is the code for how to create a single node. Okay, now with the help of these single nodes we have to create a list. So let us talk about how to create a list. So defining the class linked list. So I will declare a class linked list. Name is linked list. Now this class I am going to create the links in between the nodes. Okay, now this is a linked list, and as we have discussed, there is one node head which always points to whom? The first node. So we have to create one pointer. Okay, name it as a head, and वो किसको point करेगा? Node को. So its type will be node star. So node star head I will create, and then I will write down a default constructor, say linked list. Okay, no parameterized. and I will say head is equal to null. Initially आपका list है ही नहीं, head is not pointing to anything, node is not created, so initially list is empty, so head will point to null. Okay, and then I have written the function, two functions over here. One is insert function where you have to add on data elements and create a list, and second one is display. जो आप create कर रहे हो list वो आपको display भी करना है, so you have to write minimum two function. One is insert and second one is display, and with the help of constructor list will be created. मतलब create हो जाएगा, then you keep on adding the nodes to it and keep on displaying it. Okay, so the next one is inserting a node. Now we want to insert a node, okay, to a list. So there are four cases that can arise. You can insert into an empty list. Just now suppose if we create a list, only head is there, okay, no node is there, so you have to create the first node and insert to the list. That means you are inserting into an empty list. Then insertion at the beginning of the list, matlab you have a long list but you want to insert a node at the start of the list, at the beginning of the list. Then insertion at the end of the list. After traversing the whole list, you have to add your node into the last position. And insertion in between, in middle of the list, kahin pe bhi at some position, middle position or some position which we want to add our node into, we can have the insertion. Okay, so let us talk about insert one by one. So insert at the last, wo wala देखते हैं सबसे पहले. So void linked list. Now I am writing the code. Okay, so linked list was my class and insert was the function. I am defining the insert function outside the class, so I need a scope resolution. So syntax is return type, that is void, name of the class linked list, scope resolution, name of the function, that is insert, and in bracket uska parameter, that is integer new data, starting bracket ending bracket. Now very first line is node star new node is equal to new node new data. Now check this out. I'm creating a new node. Okay, so my name variable is new node and it is a pointer of type pointer and is equal to new node. So new node, this will call the parameterized constructor of node class. Okay, सो जो नोड क्लास हम लोगों ने पहले क्रिएट किया था ना, उसका पैरामीटर कंस्ट्रक्टर क्रिएट करेगा आपका नया नोड, and you have to pass some new data, say 10 20 30 like this. Okay, so it will create a new node. Now if head is equal to null, that condition we have to check every time. अगर head null है तो आपका head should point to the new node जो आप पहले क्रिएट करोगे, right? And then return. This will occur only if your list is empty. हेड नल कब पॉइंट करेगा? जब आपका लिस्ट एम्प्टी है तो तब क्या करना है आपको? हेड विल पॉइंट टू द न्यू नोड जो अभी क्रिएट किया एंड रिटर्न करेगा. अदरवाइज ओके, आपको क्या करना है? आपका पूरा लिस्ट आपको ट्रैवर्स करना है और एट द लास्ट आपका ये जो नया नोड है वो वहां पे ऐड करना है, राइट? सो व्हाट आई विल डू, आई विल क्रिएट सम टेम्पररी पॉइंटर. सो नोड स्टार टेम्प दैट आई विल क्रिएट एंड आई विल मेक इट पॉइंट टू हेड. सो वो हेड जो है वो टेम्पररी में मैं डाल दूंगी. ओके, एंड देन while temp of next is not equal to null, temp is equal to temp of next. My temp will point to head initially and then my temp pointer will traverse the list. Temp of next null है? नहीं है. Go to the next node. Temp is equal to temp of next. Then temp of next null है? नहीं है. Go to the next node. And this we have to do until we reach to the end of the list. At the end of the list, the last node will be temp now and temp of next is equal to null. उसका next null को point करेगा, right? So at that time आपको क्या करना है? temp of next is equal to new node. मतलब last node का next अभी क्या होगा? आपका जो ये नया node आपने किया है ना, वो हो जाएगा. Okay? So in this way you can insert at the last. Let us see this with some animation. So see, I have created a new node. न्यू नोड क्रिएशन के लिए क्या है आपको? पहले नोड स्टार न्यू नोड आपको एक वेरिएबल क्रिएट करना है पॉइंटर टाइप का. सो आई हैव क्रिएटेड दैट. देन यू हैव टू से न्यू नोड विथ न्यू डेटा. सो व्हेन आई से न्यू नोड, नोड का पैरामीटराइज कंस्ट्रक्टर विल बी इन्वोक्ड एंड इट विल क्रिएट दिस टाइप ऑफ न्यू नोड, जहां पे पैरामीटराइज कंस्ट्रक्टर में क्या है, डेटा क्या होगा आपका जो आप यहां से पास करोगे वो, एंड नेक्स्ट पॉइंटर क्या करेगा, नल। ओके, तो ये न्यू नोड का रेफरेंस बना है विद द हेल्प ऑफ दिस नोड स्टार न्यू नोड, और ये ग्रीन लाइन से ये एक्चुअल मेमोरी में नोड क्रिएट हुआ है विद 10 एज अ डेटा आइटम एंड नल एज अ नेक्स्ट पॉइंटर। ना इसको मुझे इज इक्वल टू बोलना है, व्हेन आई से इज इक्वल टू व्हाट विल हैपन, हाँ एंड वन मोर थिंग, वो किस लोकेशन पे बना है, 1000 मेमोरी एड्रेस पे वो नोड बना है मेरा, राइट। नाउ व्हेन आई से इज इक्वल टू व्हाट विल हैपन, दिस न्यू नोड विल स्टार्ट पॉइंटिंग टू एड्रेस 1000। ओके, सो सी न्यू नोड में क्या आएगा, 1000 आएगा, एंड जैसे उसके अंदर 1000 आता है, व्हाई, बिकॉज एड्रेस आता है उसके अंदर, बिकॉज उसका टाइप क्या है, पॉइंटर। पॉइंटर मतलब क्या, इट विल होल्ड द एड्रेस। जैसे उसके अंदर 1000 स्टोर होता है, इट विल स्टार्ट पॉइंटिंग टू द न्यू नोड। ओके, 1000 एड्रेस को पॉइंट करेगा वो। नाउ आई हैव टू क्रिएट वन मोर नोड, हेड नोड, एंड हेड नोड हमेशा किसको पॉइंट करता है, फर्स्ट नोड को। तो हेड नोड के अंदर क्या आएगा, एड्रेस ऑफ न्यू नोड। एड्रेस ऑफ न्यू नोड क्या है, 1000, सो हेड विल हैव द एड्रेस 1000। ओके, एंड head will now start pointing to this 1000. Okay, so see, we have created a new node, we have created a head, and head will start pointing to the new node. Okay, so this is about creation. Fine, now we have to see insert at the last. So check out कि हम लोगों के पास ये वाला list already suppose created है, the way we have created right now one node, we have created other nodes also. So we have this list created initially. So in the list we have 4 items. 11 is stored at 1000 location, 98 is stored at 2000 location, 39 is stored at 3000, and 46 is stored at 4000. So this is our list. Our first element is 11, head उसको point करता है, head में क्या stored है, address of first element, that is 1000, and our last node is 46 which is stored at 4000, and वो null को point करता है उसका next pointer, right? So ये मेरा complete single linked list है, and I want to add one node at the last position, मतलब 46 के बाद मुझे एक node को अभी add करना है, right? So सबसे पहले हम लोग एक temp node create करेंगे। डिक्लेयर कैसे किया, node star temp। node star temp क्रिएट करने से आपका ये temp node आ जाएगा, and is equal to head, मतलब हेड में जो भी है ना वो टेम्प में जाएगा। हेड में अभी क्या है, 1000 एड्रेस, तो वो टेम्प में जाएगा। सो टेम्प में क्या आएगा, 1000, एंड योर टेम्प विल आल्सो स्टार्ट पॉइंटिंग टू होम, द फर्स्ट नोड नाउ, बिकॉज उसके अंदर 1000 एड्रेस आया, राइट। सो टेम्प विल स्टार्ट पॉइंटिंग टू द फर्स्ट नोड, ठीक है ना। नाउ मुझे क्या करना है, चेक करना है कि टेम्प ऑफ नेक्स्ट इज इक्वल टू नल है क्या। तो अभी टेम्प ऑफ नेक्स्ट में क्या है, 2000, वो नल है क्या, नहीं है। तो मुझे क्या करना है, टेम्प इज इक्वल टू टेम्प ऑफ नेक्स्ट। तो टेम्प इज इक्वल टू टेम्प ऑफ नेक्स्ट, मतलब अभी टेम्प में क्या एड्रेस जाएगा, 2000 एड्रेस जाएगा, राइट, एंड इट विल स्टार्ट पॉइंटिंग टू द सेकेंड नोड। फिर से चेक करना है, ये लूप के अंदर है, टेम्प ऑफ नेक्स्ट इज इक्वल टू नल है क्या, नहीं, अभी टेम्प ऑफ नेक्स्ट इज इक्वल टू 3000 है, राइट। सो व्हाट आई हैव टू डू, टेम्प इज इक्वल टू टेम्प ऑफ नेक्स्ट। सो टेम्प में अभी क्या जाएगा, 3000, राइट। तो 3000 टेम्प में गया, तो इट विल स्टार्ट पॉइंटिंग टू थर्ड एलिमेंट। नाउ अगेन वी हैव टू चेक, टेम्प ऑफ नेक्स्ट नल है क्या, नहीं, अभी टेम्प ऑफ नेक्स्ट क्या है, 4000 है। सो वी हैव टू डू वन मोर टाइम, टेम्प इज इक्वल टू टेम्प ऑफ नेक्स्ट। तो अभी टेम्प ऑफ नेक्स्ट क्या है, 4000, तो टेम्प में अभी क्या वैल्यू आएगा, 4000, राइट। एंड जैसे 4000 वैल्यू आता है, टेम्प विल स्टार्ट पॉइंटिंग टू द फोर्थ नोड, ओके, एट 4000 मेमोरी एड्रेस। अभी चेक करो, टेम्प ऑफ नेक्स्ट नल है क्या, यस, टेम्प, दिस इज माय टेम्प, एंड ये नेक्स्ट, टेम्प का नेक्स्ट क्या है, अभी नल है। तो व्हेन टेम्प ऑफ नेक्स्ट इज इक्वल टू नल, आपको अभी क्या करना है, एट दिस पोजिशन आई वॉन्ट टू इंसर्ट माई न्यू नोड, राइट। सो सपोज दिस इज माई न्यू नोड 72 नल, ये मैंने करके रखा है 72 नल, दिस इज अ न्यू नोड आई हैव क्रिएटेड। तो अभी मुझे क्या करना है, टेम्प ऑफ नेक्स्ट इज इक्वल टू न्यू नोड, मतलब अभी टेम्प ऑफ नेक्स्ट, ये था टेम्प ऑफ नेक्स्ट पोजिशन, जहां पे पहले क्या स्टोर था, नल था। तो मुझे क्या देना है, टेम्प ऑफ नेक्स्ट इज इक्वल टू न्यू नोड। न्यू नोड कहाँ पे है, 5000 एड्रेस पे। मैंने क्या करना है, टेम्प ऑफ नेक्स्ट, मतलब ये टेम्प, उसका ये नेक्स्ट, वहां पे मुझे क्या स्टोर करना है, न्यू नोड का एड्रेस। न्यू नोड का एड्रेस क्या है, 5000। So I have stored 5000 over there. और जैसे ही temp of next 5000 हो जाता है, this particular node will start pointing to this. Okay, ये फोर्थ वाला नोड कहाँ पे पॉइंट करेगा? अभी 5000 एड्रेस को पॉइंट करेगा. एंड 5000 एड्रेस पे जो नोड है 72, ये नया नोड है, इट विल स्टार्ट पॉइंटिंग टू नल. ओके, उसमें उसका नेक्स्ट पॉइंटर कहाँ पे? नल. तो अभी क्या हो जाएगा? द न्यू नोड विल बी एडेड एट द एंड ऑफ द लिस्ट. I hope it is clear to you how we have inserted a new node at the end of the list. Okay. Now let us discuss about inserting a new node at the beginning. Right? At the beginning of the list, we have to insert a new node, and let us see the function for that. So as we have seen previously, we have a class called as Linklist. The function name is insert at begin. Its return type is void, and as we are writing it outside the class, we are using scope resolution operator, and its parameter is say bdata of type integer. Now we have to insert a new node. So first of all, we will create a new node. So node star new node is equal to new node with bdata as a parameter. So it will call the parameterized constructor of our node class, and it will create a new node. And we know when we create a new node, the first part data we have to store, and in the second part we have to store null, okay, through the constructor of it. Now new node of next is equal to null. Okay, and if head is equal to null, head is equal to new node. That means if it is our first node, list is empty, our head will point to the new node as a first node and return. Else, if we have the list already created and we have to insert our new node at the beginning, then what you have to do? New node of next is equal to head. Initially head was pointing to the first node. Now new node of next will be head. Okay, and head is equal to new node. So what will happen? New node will be, when you say new node of next is equal to head, means what? Before head the new node will be placed, and new node का next अभी head हो जाएगा, मतलब head will become the second node in the list. Okay, head is equal to new node, and then new head will be आपका new node. Okay, head always points to the first node, so आपको new node का address head में डालना है, so that head will start pointing to the new node as in first node. Okay, so this is through the code we have seen. Now let us see this through the animation. So suppose we have this list already created. There are 4 elements, 4 nodes, 11, 98, 39 and 46. 11 is at 1000 address, second node is 2000 address, third node is stored at 3000, and fourth is at 4000. Okay, and this is my new node which I want to add. I have created this new node 87 null, and it has been created at 3400 address. Now I want to add this 87th node as the first element over here. Okay, initially head is pointing to what? First node of your list. That means at 1000 address head is pointing to 11. Okay, now what I want, 87 should be added before 11. Okay, so what you have to do? Only two things you need to change. New node of next is equal to head. Okay, so this is my new node. New node का next अभी क्या है? Null. So what you have to do? New node of next should contain what? Head. Okay, head में क्या है? So that it will be populated 1000. Head में क्या था? 1000. So 1000 will be stored in a new node of next. Now head is equal to new node. Okay, this is the second thing. जैसे मैं यहाँ पे 1000 देती हूँ, okay, whenever I write 1000 over here, it will start pointing to what? Address 1000. See, now this node will start pointing to this. Okay, and second line क्या है? Head is equal to new node. Head should always point to the first node. Okay, so head अभी पहले यहाँ पे point कर रहा था. Now head should start pointing to this. So head is equal to new node. So head में अभी मुझे क्या डालना पड़ेगा? Address of the new node, that is 3400. And जैसे मैं बोलती हूँ head is equal to new node, address of 3400 will be stored in head, and head will start pointing to the first node. Okay, and this is how you have inserted a new node at the beginning of the list. Now list will be like this: 87, 11, 98, 39, 46, where head is pointing to first node, that is 87. Okay, Now, the next one is traversing a linked list. So to traverse the linked list, we need a walking pointer. The pointer which we have taken temp, it is a walking pointer. So we want some temporary pointer, a walking pointer, which is a pointer that moves from node to node as each element is processed. So we start traversing by setting the walking pointer to the first node in the list. So our walking pointer will start from the very first node, and one by one it will travel through all the list. Okay. Then using the loop, we continue until all the data has been processed. Each iteration of the loop processes the current node and then advances walking pointer to the next node. So while temp of next is not equal to null, temp is equal to temp of next. And your temp should start from head. That was the loop. When the last node has been processed, the walking pointer becomes null and the loop terminates. Okay. So let us see about it. It will be useful when you have to insert in between. So let us talk about it. Insert at a middle function. Okay. Now you want to insert at some middle function like